An object is in motion if the object changes position relative to the reference point, which is a place or object that can be used to determine if an object is in motion. Like on a ferry boat, the object is moving away from the shoreline, the reference point. And once you know a moving object's reference point, you can calculate the speed, velocity, and acceleration of the object. Speed is the distance traveled by an object, divided by the time it took to travel that distance. So, if you're trying to find out how fast you move from class to class, you need to find the distance and the time it took to get there. There is more to motion than just speed. There is also velocity, which is the speed of an object moving in a particular direction. Objects in motion can have the same speed but different velocities, like when one turtle is going west at 3 miles per hour and another is going south at 3 miles per hour. They have the same speed, but their velocities are different because they are going different directions, west and south. Many people think that velocity and speed are the same thing, but velocity is a vector, so it has a magnitude, and speed is a scalar, so it doesn't. Most objects do not have the same velocity throughout their entire movement. The rate at which velocity changes is called acceleration, and most people think that acceleration is speeding up, but actually, scientists use the term for any type of velocity change, which means if you're in a car and it speeds up, slows down, or changes direction, you're accelerating. To figure out your acceleration, you have to divide your force by your mass. There are also Newton's laws of motion. There are 3 in fact. The first is the law of inertia. This states that an object in motion stays in motion, and an object at rest stays at rest. Have you ever jolted forward when a car stopped? You jolt forward because of inertia. The second law states that force equals mass times acceleration. The third law states that for every action, there is an equal and opposite reaction. Like when you walk, you move forward while the ground moves back. Your feet push the ground back, which moves you forward. Who would have known we use these laws every day? A force is a push or pull exerted on an object. When you exert a force on an object, you change the object's motion. Like whenever you kick a football, lift a book, or pedal your bicycle. You may think that a larger object exerts a greater force than a smaller object, but the truth is, it doesn't matter how large it is. The mass of an object defines how great the force is. Force is mass times acceleration. Although acceleration is always caused by a force, not every force causes acceleration. This is because several forces can act on an object at the same time. This can cause balanced and unbalanced forces. If it is a balanced force, then the net force is 0, but if it's an unbalanced force, then the object will move in the direction of the greater force. Force is measured in newtons. A net force is the larger force minus the smaller force. Like if my right and left hand both push on this bottle at the same time in opposite directions with the same force, it has no net force. Therefore, it won't move or change directions. But if my right hand pushes with a greater force, then the bottle will move towards the left. When the force of gravity pulls downward on an object, the object accelerates. We will do an activity to find out if the height from which an object falls is related to its acceleration. First, we're going to divide the modeling clay into 4 equal pieces. Roll each piece into a ball so that I have 4 identical balls of clay. So now we're going to drop each clay ball from different heights. The first one we're going to drop at 36 inches. The next one we're going to drop at 27 inches. Next we're going to drop it from 18 inches. And the last one we're going to drop from 9 inches. This one was at 36, this one was at 27, this one was at 18, and this one was at 9. See how each ball is differently flattened. The one at the largest height is flatter than the one at the smallest height, which means that height must play a part in acceleration.